You guys like to cut it really close, don't you? All right, let's get things posted up. Oh my gosh, there's students. We do have class today. You guys gotta stop scaring me like that. All right, so is that everybody for today? I think so. Well, good morning and welcome to day, I guess it is day 2 for you, technically. It feels like day 3, but you guys had that work day. So you got a little bit extra time to work on the semester review. But now we're gonna take today to finish it. So if you haven't finished it already, I know some people did. They got plenty of time yesterday after work, got that all sorted out. So at the very least, take the time and work on those questions and just get it finished for today. And then secondary, even if you have finished it, if there's anything you're still questioning, please ask. Otherwise, I sit here and continue to have nothing to do. That's not true. I'm actually still working on writing the final exam. But you have all of the answers now. Okay, I got these all up Monday. So all of the evens are there in my handwriting, all the odds, of course, available down below already. And if that's not enough, ask away. I'd be happy to walk through the entirety of any questions on here. Can we do like one problem of each kind? Short answer, no, there's too many kinds. I'm happy to answer a specific question for you, but if you want one of each kind, that's what the review was. I got one. All right, fire away, Alex. So number 16. And chapter 1-21. Yep. This guy used the graph of the function to find. I thought these were great questions. Relatively straightforward, reading stuff off the graph. All right, there were multiple parts there. Which one is giving you trouble? All of them. Okay, fair enough. Okay, here is the graph. Okay, so they tell you this is function f of x. So when they say find f of 3, this is reading function notation. This means 3 has been substituted in for x into the function. So you go to the graph and say when x is 3, 1, 2, 3, up to the function there, that function value, the y value is 1. F of 0. function of 0. So start at x equals 0, go up to the function. What value of y does it hit? That's 1 again. F of -4. So back to 1, 2, 3, -4. Up to the function, and it's just cut off. They went to arrow just before they nicked it, but it looks like it's about to intersect right there, which would be 1, 2, 3, 4, 5, 6. So the value is 6. Right? That's all that is. All right, D says find x where f of x equals 3. Okay, so where does the function equal 3? So pick we could drop imagine a horizontal line here at 3. Where does it cross the function? Those 2 points, they even highlighted them for you. It's as if they knew ahead of time what was coming. And so then we read down to the x-axis. This looks like about -1.5, and this is 2. And then same deal with E. Where does the function equal 0? That's going to be right on the x-axis there. Where does it cross? Where's the 0 of the function? That's like half our job here in pre-calculus and calculus is finding the zeros. And so that would be right there in between 3 and 4, so 3.5. Where it says equals 3 means the y. Look, f of x means the y. So yes, when f of x equals 3, it's where is the y value? 3. Okay, if this is the year it takes you, so be it. You've got to get used to function notation. Calculus will not be written in y equals x. Calculus will be written in f of x equals x. Okay? Ditch y. Forget y. Y is no longer important. Y is just any other letter variable. It does nothing special. Okay? You spent all that time in pre-algebra and algebra 1 drilling into y in terms of x, independent in terms of dependent. Like, that's great. But now we got to drop the y. Function notation becomes so much more powerful, so much more common. Got to get used to that. I want that to be as instinctive and obvious when you encounter it as y would be. Because you're going to get to calculus, and suddenly they're going to add maybe not calculus 1, but right, you go 3 dimensions, and now you got x, y, and z. And it's like, okay, what variable is a function of which? Okay, that becomes very important. Got to be more flexible. Okay, number 10 on the first part. By first part, I think first page. So the first number 10 up here. Yep. Yes. This is a good one. This is the solve by quadratic techniques. Okay. You treat this. Give you a. Yeah, we'll keep using blue here. All right. We're going to set u equal to x to the 1/3 power. Okay? Because x to the 1/3 squared, you multiply the exponents, would become x to the 2/3, which is very useful because now I have a x to the 2/3 and I have a x to the 1/3. So this whole function turns into 2u squared plus 3u minus 2 equals 0. And now that's just a quadratic. I can solve this using any number of quadratic methods. We could try factoring it if it's factorable. We can use the quadratic formula. If it's not, you could complete the square if you're feeling ambitious, right? Any of those will result in an answer for, u is equal to this and this. And then you take those and sub them back into here to get the final values for x. Okay, so let's try that now. So we've got, this is our quadratic. Is it factorable? Can we think T-chart? Right here, are there factors of, let's see, 2 times -2, -4 that will add up to +3. If we have like -1 and +4, 4 minus 1 gets us 3, that'll work. So this becomes 2u squared plus, let's do the 4 first. 4u minus 1, u minus 2. Okay, factor by grouping, we can take 2u out of here. That leaves us with u plus 2. We can factor a -1 from here. That leaves us with u plus 2. We got the same thing both times. Very good. So 2u minus 1 times u plus 2. Good old ZPP, set each one equal to 0. 2u minus 1 equals 0, or u equals, we'll add the 1 and then divide by 2. So that gets us to 1/2. And u plus 2 equals 0. Solve for u, subtract 2 from both sides. U equals -2. But we're not trying to find solutions in terms of u. We want solutions in terms of x. So we have to solve for x. So now we bring back this equation. We say, okay, if 1/2 equals x to the 1/3, or -2 equals x to the 1/3. All right? And so to solve for x, to undo that to the 1/3 power, just raise everything to the 3rd power. And then 3 times 1/3 is 1. So 1/2 to the 3rd. And -2 to the 3rd gives us, where'd they go? Over here. -8 and 1/8. All clear? Okay, good. Next question, whenever anyone is ready. And if you're watching the YouTube video later, remember, use that fast forward button to skip ahead until you see my screen change again. As you see the screen moves, then you know to stop and listen in to the next answer. Number 18, okay. Same as 17, most likely. This 18, the reading from the graph, yes. Same process as 17, and same process as 16 that we just went over. The thingy was different. Oh, come on. We can use better vocabulary than that. I think you mean the function? Yeah, the only issue with 18 was they still wrote y equals f of x, and then all the questions are p of something. b is not 1. That's a d. Does not exist. There is no part of this function where the function equals 0. It never crosses the x-axis. All right, 2 questions in. We've got number 12. Which 12? You're gonna have to specify from what section. Unless there's only one number 12. The first one. Okay, up here. This guy, okay. And then I'll get to Alex's next question after this. All right, x times something cubed minus 2 times that same something also squared. Okay, we've got repeats there, very good. So I would start by factoring that guy, right? Treat this as one unit. Let me switch to blue here. And you can factor that out, and we can say we've got a 3x minus 5, I can factor 2 of those out, squared, times whatever's left. So what would be left was an x times a 3x minus 5. And what would be left here is just the minus 2. Right? So that's equal to 0. Not interfere with the other one there. Okay, so now I've got some multiplication here. My main expression here is represented as a multiplication, so I can immediately use ZPP and break off this half to say 3x minus 5 squared equals 0, and solve that for x. I know I'm going to get a duplicate answer here, but it's still the same answer. So square root both sides. Hey, square root of 0 is 0. How about that? That's handy. Add 5, divide by 3, x is 5/3. So there's that answer. Okay? And then over here we've got x times 3x minus 5 equals, oops, not equals, minus 2 equals 0. All right, well, you could try putting it seems tempting to move the 2 over first, but then I've got x times the other stuff equals not 0. I can't use ZPP unless it equals 0. And I can't use ZPP yet because it's multiplication and then there's this extra subtraction tacked onto the end there. So my best bet forward is probably go ahead and distribute that x and just turn this into a quadratic and work it from there. Okay, this is like a partially factored but not quite quadratic setup here. So let's just distribute that x. 3x squared minus 5x minus 2 equals 0. Now can we factor this properly? Let's see, can we think of a number? 3 times negative 2 is negative 6. Two numbers that multiply to negative 6 and add to negative 5. Let's see, multiply to negative 6 and add to negative 5. Well, since anytime you have results like that that are 1 away, the answer is always yes. Right? It's something and 1, right? 6 and 1, so let's make that plus 6x. Nope, we got to get negative 5, so the 6 has to be the negative. Minus 6x plus 1x. Minus 2 equals 0. Factor by grouping, pull out 3x, leaves us x minus 2. Pull out a negative 1. Nope, just positive 1. That's fine. Times x minus 2, because I want to make those match. Equals 0. So we get 3x plus 1. There. Times x minus 2 equals 0. Now I can ZPP 3x plus 1 equals 0. X minus 2 equals 0. And solve for x. Subtract 1, divide by 3 minus 1/3. Add 2 to both sides. X equals positive 2. Positive 2, negative 1/3. Okay, that takes care of that guy. Next up we had number 19, do we sub the equation? Okay, I'm going to guess you're continuing on from those. Read the graphs. 18, 19. Yep, that's exactly it. You can think of that as sub the equation. So anytime you see f of x, you stick all of this right there. F of x plus h, you stick all of this right there, except within this, every time you see x, you replace it with x plus h, right? So we would like to start this off. You can see the full answer down below, but you would start off, since this is f of x plus h first, we start with f of x. So 3, but instead of x, it's x plus h, comma, squared, minus 4 times x plus h, right, and so on. And then some terms will be able to combine and reduce. Not all of them will. As you can see, the answer to number 20 here gets a little wonky depending on how much you want to do. So this is just the fresh setup. It would require, one, you've got to distribute this division of h onto all of the terms, some of them that helps reduce them, some of them not, and then trying to rationalize this denominator to make that cooperate. It's a little bit messy. doable. Do what again, 19 or 20? Both right now 19, okay. All right, do you remember composition of functions? Would it be like find f of x plus g of x? Right? And so you would take, oh, well, f of x was this, and then g of x was that, or whatever. And you would literally have to write all of this out, big plus, all of the next one. And then sometimes there'd be some like terms, and you could just combine them, and it would reduce a little bit. That's what's going on here. Except instead of f of x and g of x, for starters, we've got a subtraction here. And g of x is just normal. F of x, though, is x plus h. So it's still substitution into function notation. Just like this p of 1 means put a 1 in every time you see an x. F of x plus h means put x plus h in every time you see x. So instead of x squared, it's x plus h squared. Minus 4 times instead of x, it's x plus h. And then still plus 1. So that's f of x plus h. Minus all of f of x. Well, f of x is just all of this right here, so just copy that down exactly. That part doesn't change. All of it divided by h. Okay. Are you comfortable with that setup? No, you're not comfortable with it. Okay, what's making you uncomfortable about it? When they say x plus j and there another term x, you had x plus j. Well, h in this case. Another term x. Okay, this comes to what is a variable. A variable is a placeholder, okay? You've got to expand your scope here. Okay? And this is one of the reasons I started using coolmath.com, because coolmath.com introduces function notation, and it says, find f of blob. Okay? I don't care what the actual input is, even if it's complete nonsense. You are still going to write, okay, you told me, right? This is malicious compliance to a T, okay? Beautiful subreddit, fantastic stories, or whenever, like, I'm trying to think of a good example at home. You know, something where your mom tells you to do something and you think it's stupid, and it's like, okay, fine, I'm just going to interpret it exactly literally the way you said, even though you know that's not what she wants, right? But you're ticked off for whatever reason, and you're just like, okay. Right? So You say, okay, I'm doing exactly what you said. You said find f of blob. The input is blob. So every time I see x, right, this is f of x. F of x looks like this. The input is x, and so every time you see the input, it shows up as x. I want f of blob. So I'm going to have everything is exactly the same, except every time I see input indicator, right? That's what the x is flashing to me in this function. Hey, x is the independent variable. This is standing in for whatever goes here. And it's telling me, hey, put blob there. Okay, you said so. 3 times blob squared, except that doesn't really look quite right. So we put it in parentheses, just so we know that's the whole blob squared, not just the b on the end. All right, minus 4 times blob plus 1. All right, there, I did it. I did f of blob. Are you happy now? All right, and it looks ridiculous. It absolutely looks ridiculous. This is completely meaningless nonsense. That's okay. Functions don't have to make sense. A function is more than just a math equation. It's a process. Remember the function machines from Algebra 1. Okay? I think a lot of you were in Nensel's class, right? You had to build a little function machine. Okay, whatever. You stick an input in, it puts an output. I stuck blob in as my input. This is the output, okay? Weird stuff happened. That's okay. I put weird stuff in. That's to be expected. So all this is saying is, hey, I want slightly weirder stuff. X plus h. How do I know when to add x plus h or the whole expression? I'm following the directions here. Let me clear out some of this extra stuff. These are the directions right here. Find this for this function. Okay? This only references one function, f. Okay? There is no function g mentioned here. Okay? So within the question, I'm only given the one function as defined. I only need that one function. So in the first part, right, I'm breaking this down, looking at this setup. I could give you something completely different. I could say, find for me f of 3 plus f of 5 and divide by f of x. Okay? And so you would look at this and you would break this down. And, oh, okay, so now it's the functions are the items. And you would notice that overall this is one great big division. And in the numerator, I am adding 2 things. Do we agree with that? When you look at this, can you see the structure? This is one big division, and in the numerator, I am adding 2 things. No. No. Forget the numbers. Okay, I know exactly what your problem is. All right? You're not seeing the structure of things. You're missing the forest for the trees. Okay? And I'm just going to look at how are we doing on time here? Okay, I'm going to make a note to myself. We'll find you other resources. Okay, for resources to help notice structure first. Okay. Don't know how much time I'll get to it before this semester ends, but we will fix this, okay? And this is not just him, this is everybody, okay? If you want to succeed in calculus, you need, as I've mentioned, basic understanding of what is the calculus concept going on here, and mastery of algebra basics, which algebra 2, I guess, qualifies under the basics, right? Knowing all these types of functions and what to do with them, how they react and behave. That's what we've been studying, talking about. One of those algebra basics is understanding the structure of things, the underlying, what does this represent? Okay, this is a language, okay? Because when I start putting letters together, you immediately have a picture in your mind, don't you? I just put symbols on the page. You now have an image, right, of a creature, a relative size, a sound it makes, general habitats. You know all of these things about elephants. It immediately springs to mind. I'm like, okay, elephants, yes, I know all this stuff about them. What do you want me to do with it? Mathematics is exactly the same. We have a written language. This is it. That is expressing multiple ideas at the same time, just like elephants, right? They have a size, they have a shape, they have a color, they make a sound, they live in certain places, they eat certain things. Okay? All of that needs to come to mind when you see this. You need to see this is order of operations, okay? A big division, and within the numerator, right? So remember, division bar represents that first, right? That is the same as 1 plus 2 over 3. This is how a lot of those stupid Facebook, everybody gets this simple math question wrong. This is how it all breaks down because they mess up the division here. Okay? We have a thing. Before I interpret what that thing is, notice first, top down, structure first, a thing plus another thing divided by a third thing. Next level, notice there is a relation between all of those things. Hey, all these things have F in common. They're all F parenthesis something. Oh, okay, so I need to understand what F parenthesis of something is. That's the next level. I know function notation, which means I understand F parenthesis, or really any letter, from technically any of the alphabet, but most conventionally the front middle, F, G, H, right, means a function of 3 plus the same function, we repeated the same letter, of 5, all divided by function of x. Okay, next level. 3 and 5 and x are my inputs into the function. I'm going to have to input into that function 3 times, one for this time, one for that time, one for the next time. Next level, 3 and 5, those are integers. Those are regular numbers, I recognize those. I can put those in, think ahead, I don't even know what the function is yet, but I know typically functions, if I put a number in, I'll get a number out. But I know down here, if I put a letter in, I will not get a number out. And most likely, I will not even get just a letter out. I will get some large expression of stuff. Numbers and letters and all combined in ways. So I can predict ahead of time, I'm going to put a number into the function, I'm going to get a number here. I'm going to put a number into the function, I'm going to get a number here. I'm going to add those two numbers. That will work just fine. I can do that part, I'll get a number. Then I will set that over top of some expression f of x. I don't know what it is, but it'll be there. It's whatever I get. And please, please, please do not say this is equivalent to f of 8. Nope. 3 and 5 are completely detached from each other via the functions. Right? You are not adding 3 and 5. 3 plus 5 looks like this. It could, if you really wanted, let me give myself a little bit more space there. Look like that. You can stick parentheses around anything you like. That won't change it. You're still adding 3 and 5. But as soon as you introduce other letters, there are other things going on. Okay? Take that as like rule 0. If there's other letters and numbers involved, other things are going on. Just like if I was to stick a 1 here, that's no longer 3 plus 5. You stuck a 1 in front of the 3. Now it's 13. Agreed? I changed the number by sticking another thing in front of it. Same here. I changed the number by sticking another thing in front of it. All right. We're running out of time. So I'm going to wrap this up. And again, I will send more resources, make those available to everybody. But this is why, like, all of these skills build up. Why you're so confused by this is because you were already confused by this, right? You didn't have that same instinct of, oh, what does this actually represent here? Because this is not that much different from here. Main difference is I put the simple ones on top, right? This will converge to a number. This will make a number. They'll combine to make just a number. And the complicated stuff is on the bottom. Here it's just H. It's a single letter on the bottom. The complicated stuff is on top. But this one is just f of x. It's exactly the same as you have here, as I've rewritten there. This is f of x plus h. So it's the blob. I've put different inputs into there. It's letters, so it's not going to give me a single number in the end. And the reason we are looking at this equation in the first place and not trying to do things like this instead is because this is the difference quotient. Okay, we've seen this before. It was in our notes, possibly came up a couple times. This is the general form for how to find the slope of anything. Or the slope, I guess, technically between 2 points. So when we get those points really close together, now we start talking calculus, right? So this is the bridge. If I had to pick one equation, what is the bridge? What is the pre-calculus equation that goes from algebra to calculus? It's this guy right here. Okay? So I will leave you with that idea. Please keep working through to finish this review. If you do have questions, feel free to email me. I will try to get back to you as soon as possible. Okay? But I'm generally available during waking hours. Happy to help you. And yes, I will get to those other resources. All right? With that, it is it time to go? 35. Yeah. There it is. 35. All right. You are dismissed. So long. Farewell. Enjoy the rest of your day.